This short video is going to go through part B of this question, which is going to be looking at the weight fraction for this particular question. So the question is asking to determine the weight fraction for the solid and the liquid of a 90% KDM mix. So the first thing is we're still looking at this 90% line over here. So that's the temperature, the mixture line that we're looking at. So that's the one we're going for. And then part I, or the first part, is looking at the temperature of about 250 degrees centigrade. So that's this temperature over here, which is why we've got the dot there. And whenever we're looking at weight fractions of solids and liquids, this is when we use this lever arm rule. So we use that lever concept where we talk about a lever arm. And that's how to know when to use the lever arm, essentially. So we create a lever arm which is along that temperature line. So that's the temperature line. And as we've seen with these eutectic systems, the solid phase goes up along the edges and the liquidus line is as we previously had it coming on to the liquidus line. And so what that shows us is that at this particular temperature, we have a lever arm which is running from about 75% KDM up to 100% KDM. So 75 to 100, that's about 25 as a total distance for the lever arm. And then what we see is that the lever arm itself has got a distance of 10 to that side and a distance of 15 on this side. And just as we did with our previous systems, we look at these systems in terms of liquidus and solidus solutions. So the percentage of solid, which we're calling alpha, is going to be equal to the distance from this temperature to the liquidus line divided by the total lever arm, which is 25. And the percentage of liquid is the distance from here to the solidus line divided by 25. And then you can use your calculator to work those two values out. I'm just going to quickly do that now. So 15 divided by 25, 60%. And this must be 40% there. So that gives us an indication of how much liquid and how much solid is in our mixture at that specific temperature for this particular composition.